Probability topics. It is often necessary to guess about the outcome of an event in order to make a decision. Politicians study polls to guess their likelihood of winning an election. Doctors estimate the treatments needed for various diseases. You may have visited a casino where the people play games and they choose the games that they are going to play based on the belief that the likelihood of winning is good. You may have chosen your course of study based on the probable availability of jobs. You have more than likely used probability. In fact, you probably have an intuitive sense of probability. Probability deals with the chance of an event occurring. Whenever you weigh the odds of whether or not to do your homework or to study for an exam, you are using probability. In this lesson, you will learn to solve probability problems using a systematic approach. Let's look over some terminology first. An experiment is a planned operation carried out under controlled conditions. In a chance experiment, the results are not predetermined. An example is roll one fair six-sided die and observe the face that is showing. Another is draw one card from a regular 52-card deck that has 13 hearts, 13 clubs, 13 spades, and 13 diamonds. An outcome is the result of an experiment. So one outcome of rolling a fair six-sided die is a 1. The face of the die showing is a 1. Or in the picture here on this slide, we have 2 dice and they're each showing 6. A sample space is all possible outcomes of an experiment. So all possible outcomes for rolling a fair six-sided die are 1, 2, 3, 4, 5, and 6. An event is any combination of outcomes. Uppercase letters are used for events. So for example, let event A equal rolling a face greater than 1. So that would be rolling a 2, 3, 4, 5, or 6 when you roll one fair six-sided die. Let event B equal rolling an odd numbered face. So that would be rolling a 1, 3, or 5 when you roll one fair six-sided die. The probability of any outcome of an experiment is the long-term relative frequency of that outcome. Recall that relative frequency is the fraction of times an answer occurs. So an example, all possible outcomes for rolling a fair six-sided die are 1, 2, 3, 4, 5, and 6. Each of these outcomes is equally likely. If we roll the die 600 times, we would expect 100 faces that showed a 1. So the long-term relative frequency or probability of rolling a 1 is 1 out of 6, or 1/6. And we write it the way it's shown here. The probability of A being to rolling a 1 equals 1/6, 1 out of 6. Equally likely is when each outcome has an equal chance of happening. So for example, all possible outcomes for rolling a six-sided die are 1, 2, 3, 4, 5, and 6, and each outcome is equally likely. So if we roll the die 600 times, we'd expect 100 times it would show a 1, 100 that it showed a 2, and so on and so forth. Now, to calculate the probability of an event A when all outcomes in the sample space are equally likely, you count the number of outcomes for event A and divide by the total number of outcomes in the sample space. So for example, if you toss a fair dime and a fair nickel, the sample space is heads, heads, tails, heads, heads, tails, and tails, tails. The sample space has 4 possible outcomes. If we let A equal getting one head, then there are 2 outcomes that meet this condition, head, tail, and tail, head. So the probability of A is 2 out of 4. Or you could reduce that to 0.5. There's a 50% probability of getting heads, tails, or tails, heads. Suppose you roll one fair six-sided die with the numbers 1, 2, 3, 4, 5, 6 on its faces. We're going to let event E equal the rolling a number that's at least 5. So if it's at least 5, then there's two outcomes, 5 and 6. So the probability of E is 2 out of 6.